Hello viewers, welcome back. We are now looking at the time quantity of money. So we are now looking at the time quantity of money. That's what we are focusing on for now. Time quantity of money. Now, some of you guys may be surprised that this course is titled The Time Value of Money, as you can see up here. In fact, the process of moving cash flows, the process of moving cash flows forward or backward is usually referred to as time value of money. It's usually referred to as time value of money. Now, here we prefer to use time quantity of money because it is really the quantity. It is really the quantity of money that is changing over time. The value of money can also change over time, and the change comes about because of the inflation rate. It is the inflation rate that brings about the change of money over time, because inflation essentially erodes the value of money over time. But for now, in this discussion, we are going to focus on the quantity. We are going to focus on the quantity and how that quantity can change over time. So I want you to get me right. I don't want you to assume that we are ignoring time value of money. Yes, we know the value of the money changes over time because of the inflation. Because the inflation erodes or it takes away the value of money over time. As it grows, you find that something that was costing 1 million today, US dollars, in 2 years' time, when the inflation is high, it may not cost the same. You may find it is going to be costing 10 million. So that's what we call inflation, meaning the value, the item that was being purchased at 1 million US dollars is now being purchased at 10 million US dollars. It means the value has changed over time because of the inflation. But here what we are focusing on is actually the quantity, that we've moved from 1 million to 10 million. We are talking about the quantity because it is actually the quantity that is changing. So that's why we are focusing our discussion on the quantity. Now, let's bring into this small diagram. Let's first have this off. We try to have that diagram into focus. I want us to look at this diagram right here. This diagram right here. So this simple example that we have for now, the first thing that you can notice is that there are some numbers that are in blue. This one is in blue, this one is in blue, and these ones are also in blue. So those are in blue font. In other words, the font color is blue. And we've said from our previous courses that our blue font is typically used in financial modeling to portray an input. In other words, those are inputs, whichever that is in that blue, whichever is in that blue is looked at as input. Now, so here we have our input. The first input as for that year one, this is the year. Year one is 40,000 US dollars. So the 40,000 US dollars, We are seeing this one has these years, and here we are looking at the forward movement. The forward movement of these cash flows, year 1, year 2, year 3, year 4, year 5. We have the growth rate. The growth rate, you can take it as the inflation rate. In other words, the rate at which inflation is growing. Then we are also trying to project the future cash flows here. So the question is, today in year 1, we have 40,000 US dollars as the money we are putting in the project. Or it is the money that we have, 40,000 US dollars. The question is, if you are to project these values, if you are to move from this point and you are growing it by 10%, then it will give you this value here. If you move and you grow it by 10%, like that, you grow that figure by 10%. So we have, you can see that we have a 10% year over year. This one we have a 10% in year 2, year 3, and year 5, 4 and 5 as our gross rate. And that gross rate is for this amount of 40,000 US dollars. Now, what we can see right here in these black numbers, because these black numbers here, those black numbers, those that are within the black font, we always say those portray the formulas. In other words, those numbers are formula driven, and that is the company's cash flow quantity for that year 2. In other words, we can see that from this blue one, we are now increasing from the $40,000 to that value, as you are seeing, 44,000 US dollars. And the quantity is increasing over time. For instance, the 10% growth in year 2, you can see it has increased the cash flow from 40,000 to 44,000. And there is another 10% increase in year 3 that increased the value from 44,000 to 48,400 in year 3. Meaning this 48,400 has increased by 10% to 53,240 until you reach to the last value here in year 5. But now, so if we try to look at this, if we try to look at here, the growing here, or if we try to move forward, we are always moving forward into the future. So we always grow by what we call compounding. And the value for compounding, or the formula we use, is that future cash flow will be equaling to our present value that we have for now. We multiply, then we open bracket, 1 plus R. In other words, this is how we compute the increase. If someone says something is increasing by 10%, the actual computation is that it will be 100% plus the 10%, and that will give you 110%. So if you want to find out that this 40,000 has increased by 10%, it is just a matter of saying 1.1 times the 40,000, and this will give you 44,000 US dollars. And the other person could first take the 10% of the 40,000, of this 40,000, and that will give you $4,000. Then it will be the 40,000 plus now the $4,000, and that will give you $44,000. So whichever way you go, it will actually bring you to the same thing. But if you look at the formula that we have here, the one for future value. This is the formula that we use for financial management for computing the future value in the process of compounding. So what we do, we get the future value. For us to be able to get the future value, it will be 40,000, which is our present value. The value that we have today is this. So we multiply that, open bracket, 1 plus, what is the growth rate? This R is our growth rate. So which is 10%. 10% is 0.1. So add 0.1 there. It will be 1.1 multiplied by 40,000. And that will give you 44. That will give you 44,000. And that's exactly what we are seeing in this. See? That's exactly what we are seeing in this small box here. That's how we got in the. So that's what we are seeing from this box that we are having here. This box right here is trying to compute that. So that the operation will actually continue up to year 5. And the value we shall get for year 5, it will be 58,564 US dollars. And that's how we've been able to compute the forward movement. That's the first way that we actually compute the amount that we shall be having in the future. And we refer to that repetition as compounding. So we compounded from the original $40,000 over and over through these years to get to the total of 58,564 by year 5. So now, hope you've been able to see how we've done the mathematics and how it works. We've taken the $40,000, we multiplied by 1 plus 10%, and that gave us $44,000. So the real takeaway from this point is that the same process that we used to compute the first cash flow here of 44,000 is the same process that we continue over and over through until we go to the different years that we have to forecast. And that's what gave us that value that we call the compounded amount of 58,564,000 in year 5, this value right here. So that's how we've been able to move in that same format. Now, it's really simple and very intuitive to move these quantities of cash flows forward into the future as they grow. That's how we forecast. We forecast by growing the first cash flow we have as our input. For example, the 40,000, and we move forward into the future for these different years up to year 5. So that's how we've been able to compute some of those things. Now, what now we are going to do, we are going to take a look at the backward movement, because in finance, it is actually more common to move in the reverse order. That's what we call the backward movement. In other words, we take a quantity of cash flow in the future and we move it backward in time. In other words, it's going to be moving backwards in time, and we refer to that process as discounting. That's what we are going to look at. That's what we are going to focus on, because always in finance, we make sure that at least we have that backward movement. We always have that backward movement in those cash flows. So let's take a look at how discounting works. Let's bring up this diagram. This diagram looks very similar with what we had previously. But we can see that there is only one key difference that we have. The key difference is this point here. The key difference is right on this, is right here on our right hand side, where we are starting from the highest value. Remember, this is the highest value that we had. So this is a backward movement. The other one was a forward movement. So we are now moving this value that we got earlier, as we are using it as our input. That's why you are seeing that this number in year 5, the number of 58,564 US dollars is actually the number that we have in year 5, and it is in the blue font. And we said blue fonts portray inputs. So we are starting from this year 5 with this value of 58,564 US dollars as our input. And we are starting from this point, and we are moving in a reverse format. In other words, we are moving backwards like this. We are moving backwards. So what we can do from this point in year 5, from this point here of year 5, is now we want to reverse the process backward. And we are going to reverse the process backwards in this format. In other words, this is our starting point, year 5. We are trying to move in this format. We are trying to move in this way, to this side. That's how we are trying to move. So we are moving backwards from the year 5 up to the year 1. And that process is what we call discounting. This process here is what we call discounting. So as you've seen, the way the mathematics would work for this is that we take the amount, this amount, 58,564 in year 5. And what we are going to do, we are going to divide that value. We are going to divide that value by 1 plus. Divide that value over 1 plus the growth rate. The growth rate was 10%, which is 0.1. And that will give us 53,240 US dollars. And this value is exactly what you are seeing from this point here in year 4. So, and that's the same thing that you are seeing from this same bracket here. We are trying to move backwards, and we are using the present value formula. In other words, we are moving backwards using the present value formula. Is future value over 1 plus r. Remember, it is always to power n. But here we are moving only 1 year. So even if you just get this of power 1, it will still give you the same answer. That's why I'm not putting in these numbers. Even the other side, I didn't put the number of years, because this n here represents the number of years. So if we continue this process backwards by 1 year, meaning since these years are not going to change, we are always going to be dividing by 1 plus 10%. So what are we going to do? We are going to make sure that at least we are dividing backwards by 1 year. In other words, we move 1 year, 1 year, 1 year until we finalize everything. Because these cash flows are also coming in year by year. So we can also see from this note right here is that the operation can continue backward to year 1 to get this value of 40,000. But now to this one, you will find that these values are actually bringing us to the value that we started with of $40,000. And we call that process discounting. So it is a discounting process. In fact, that's where you get that D. Because remember, we have the course is DCF. And this D you are seeing here, the D within the DCF model is actually this discounted cash flow. That D within there is the one that is talking about discounting the cash flows. You are taking the cash flows and you are discounting their quantities back in time to their present worth. In other words, the meaning, what the whole thing here means is that this value that I'm supposed to get in 5 years' time of 58,564, if I'm to get this money in 5 years, it will be that. But if I want this money to be given to me now, they will only give me 40,000 US dollars. So if I'm to wait, I'll make sure that I have this difference. If you less off this from this, you'll be getting the 18,564. And that difference is what is lost with time. So that's the implication from that perspective. So now, to do a DCF technique properly, we need to make sure that we have the right cash flows. So for us to do a DCF correctly, we need to have the right cash flows. Because if you don't have the right cash flows, you will not make the right computations, because all these computations are actually basing on the cash flows that we have. So if you don't have the right cash flows and the right discount rate, if you don't have the right cash flows and the right discount rate, then the cash flows, then it means you will not be able to have a proper DCF computation. So we need to have the right cash flows and at the same time the correct discount rate. And these two are the two areas where people often make mistakes. So in the next video, we are going to dive into those cash flows and discount rates and figure out exactly which cash flows to use and which appropriate discount rate that we can also use to make sure that we have the right DCF model. So we see you in the next video as we are talking about cash flows and discount rates. Thank you for watching.